In order to construct the tan graph using only a ruler, a compass and a protractor, we need to determine how tan can be represented by a height. Consider the tangent t to the unit circle at the point P 1, 0. So here we have the unit circle, and if this is the center 0, 0, then this is the point 1, 0. So this is the point P, and here we have a tangent, which is a line that touches a circle or a curve at only one point. So we see that the tangent is parallel to the y-axis. So this is the point P, which is 1, 0. This tangent is vertical. If we now take an angle A at the center and produce the radius to meet T at the point Q, then OPQ is a right angle triangle where O is the origin. So this is our angle A at the center, and we have a radius that extends beyond the circle to touch the tangent. So it touches the line T, and it touches it at the point Q. Then OPQ, so OPQ, so this angle here is a right angle, so we form a right angle triangle, OPQ, where point O is the origin. So we take an angle A at the center, produce the radius to meet T at the point Q, then OPQ is a right angle triangle where O is the origin. Then tan of A is going to be PQ over 1, which is going to be PQ, because we use TOA for our formula, and TOA represents tan equals opposite divided by adjacent. So if this is the angle A, then this is the opposite, and this is the adjacent. So it's going to be the opposite, which is PQ, over the adjacent, which is 1, because remember the unit circle has a radius of 1, and PQ over 1 gives us PQ. So tan of A gives us PQ. So tan of angle A gives us PQ. So PQ is equal to tan A. Thus, the tan of each angle A is given by the position of the point Q on the tangent T. The construction of the graph using only a ruler and a compass and a protractor is shown below. So we have the unit circle, the center of the unit circle, which is the origin, lines up with the x-axis. We start at 0 degrees, we go up as far as 90 degrees. We draw a line from the center of the circle to the tangent, and when we touch the tangent, we draw a line across to that angle. For example, here we would draw a line across to 30 degrees because this would be a 30-degree angle. Then we would have an angle of 60 degrees. We draw a line up until we touch the tangent, draw a line across until we get to 60 degrees and plot a point. And we would continue to do that until we had formed the graph of y equals tan of x. Here is a summary of the main features of all three of the basic trig functions and their graphs. So y equals sine of x is in the domain of or, the real number set, range of -1, 1, period of 360 degrees or 2 pi. Y equals cos of x is a domain of or, the real number set, range of -1, 1, period of 360 degrees or 2 pi. Y equals tan of x, domain of the real number set, without plus or minus 90 degrees, plus or minus 270 degrees, and so on. Range is the real number set, and it has a period of 180 degrees or pi. Construct the tan graph using only a ruler, compass, and a protractor. So we're going to start off by drawing in our degrees on our unit circle. So we have 0 degrees, then moving anti-clockwise we have 30 degrees, then moving anti-clockwise we have 60 degrees, then moving anti-clockwise we have 90 degrees. Next, what we have to do is extend our radii that we're after drawing into our circle so that it touches off the tangent. So this red line is a tangent to our circle at the point 1, 0. Next, what we're going to do is draw a straight line across from the point at which we've touched the tangent that is parallel to the x-axis. Next, we're going to move along the first line that we've drawn that's parallel to the x-axis. So this came from the angle 30 degrees. So we're going to go along as far as 30 degrees and we're going to plot a point on that line. Then we do the same with the next line. So this came from the angle 60 degrees. So we go along the line until we get to 60 degrees and we plot a point. Now if we want to get more accurate, we could go halfway between 0 degrees and 30 degrees, which would be 15 degrees, and do the same thing. And then we could do the same with halfway between 30 and 60 degrees, which would be 45 degrees. And we could do the same halfway between 60 and 90 degrees, which would be 75 degrees. And then I'm going to draw lines to the right of each of these points, making sure that they are parallel to the x-axis. So since halfway between 0 and 30 degrees is 15 degrees, I'm going to go across this line until I match up at 15 degrees, which is about here, and plot a point. And since halfway between 30 and 60 degrees is 45 degrees, I'm going to go along this line until I match up at 45 degrees, which is about here, and plot a point. And since halfway between 60 and 90 degrees is 75 degrees, I'm going to follow this line until I match up at 75 degrees, which is about here, and plot a point. And very important not to forget 0 degrees, which matches up with 0, 0. Now I join my points together with a curve. And remember that our graph keeps moving upwards and it gets much, much steeper, much quicker, but remember it never ever touches off 90. So 90 degrees is a vertical asymptote. Our graph never touches off 90 degrees. Now we could continue to the left of our y-axis. So we could start drawing lines or angles below what would be the x-axis. So for example here we could have minus 15 degrees, minus 30 degrees, minus 45 degrees, and so on. So if this is minus 30 degrees, this is going to be minus 15 degrees. So I'm going to draw a line across. And if this is 0 degrees, and that was 10 degrees, and that was 15 degrees, then the same distance in the other direction would be approximately minus 15 degrees, which is approximately there. So obviously if we had more space, we would see our graph would repeat on the negative side of the y-axis. So we have a section of our graph y equals tan of x, and we've drawn it using a ruler, compass, protractor, and the unit circle.